Hello, guys. Welcome to this placement preparation series where each day we discuss one aptitude question, one interview question, and one DSA question asked in many product based companies like Amazon, Google, Flipkart, which are required to crack a placement either on campus or off campus. Okay, we shall immediately start our series. Come on. Okay, our aptitude question. A person increased his walking speed from 10 kilometer hour to 14 kilometer per hour. Okay, see, there is some random person, superb. He increased his walking speed from 10 kilometer to 14 kilometer per hour and ended up covering 20 kilometers more than he normally would. So what happened here is there is a person, let us assume he is traveling the distance. Okay, in his actual speed, that is 10 kilometer per hour. Okay, now what happened is instead of going 10 he is going 14 kilometer per hour. Okay, now speed is 14 kilometer per hour. As he is going with more speed, in the same time he would cover more distance. So instead of covering D, he is going 20 more kilometers, which means he is covering D plus 20 more kilometers. Superb. This is what is given in the question. But what we need to do, bro? Okay, what is the actual distance he traveled at the faster speed? Don't confuse, it is faster speed. That means he's indirectly asking D plus 20 is question mark. As he said faster speed, that means it is case 2 itself and this is case 1. Now how should we solve this? See, here distance is changing, speed is changing, but here we know the constant thing in both the things is he is traveling both the distances in the same time. Okay, now we shall go for our normal speed and time formula. We know speed is equal to distance by time, but here as we need time, time is equal to distance by speed. Okay, from here time, what is time? Time is distance, distance is D by speed is 10. Superb. In our first case time is D by 10. In our second case time, look here distance is D plus 20, so D plus 20 by speed how much? 14. Okay, superb. Now see, this is T. In both conditions we discussed that time is same, so now we can equate these both equations. Now D by 10 is equal to D plus 20 by 14. So now cross multiplication, 14D is equal to 10D plus 10 into 20, 200, right? So let's bring this side. So 14 minus 10 gives us 4D is equal to 200. D is equal to 200 by 4. 4 ones are 4 5s are 20, 0. See, D is 50. So 50 option A, is it? No. Wait a minute. He said distance traveled at the faster speed. That's why we have to write here what is our final calculation. So our answer now is 50, which is D that we calculated, plus 20 is equal to 70 kilometers is our final answer. Where is it? Yeah, option C is our answer. Okay, 70 kilometers, C is our answer. Now our aptitude task is over. We shall now go for our next task. Come on, guys. Okay, now our second task is our interview question. Okay, what if interviewer asks us, hey, what is overloading and overriding? Okay, we shall discuss the answer, of course. It is there here itself. But wait, first we shall normally discuss what is this overloading. What are we loading, bro? And why it is over? Look, we shall go for a very simple example. In our normal human world, there are many humans who have a same name, right? Like Rahul, or something. Here, even in computers, there are methods with same name. Look, add. A same method name is repeating many times. But as even though in real world humans having same name, even they have same name, they differ in their properties. Similarly, even here in the concept of overloading, methods maybe they have the same name, but still they differ in their properties or method definitions. See, overloading is a very simple concept where there are multiple methods with the same name, but there is a change in the number or data type or the type of arguments. Simple, okay? Same method name, but difference in arguments or number of arguments or the data type of argument through which the compiler recognizes which method it should call when required. Simple. Overloading is overloading. Different versions of the same method in simple terms, bro. Now, overriding. See, loading is okay. What is this riding? Whom should we ride? Okay, it's not any different thing. Overriding means it is more complicated or even a simple one. See here, okay, bro, in overloading there is a different in parameters or anything. But look in this example, yes, similar to overloading, there is a method with, there are two methods with same name, but look at this. Their parameters are same and also the return type is same, everything is same, but still there is a change in function definition or method definition. So how would this compiler recognize whom it should call? So first, normally overriding is two or more methods with same name, same number of arguments and also same return type, but here's a catch. They, one of them will be in subclasses. Remember, you cannot define this overriding thing in the same class like this overloading. Overriding happens in different classes. More specifically, it happens in between parent class and subclass. Okay, same method name, same arguments, same return type, but in the subclass. For a real life example, look, there is something, a class called animal. So generally, sound of animals is, if we ask, if we say yes, animal will sound. But if we are specifically talking regarding a dog, yes, of course, a dog is an animal. That is why I extended it. That means I copied the properties. But still, sound of a dog is something called barking or bow bow. So in that manner, I am specifically overriding or changing the previously defined sound method, making it specifically like dog barks. So that is why, remember, it only happens in subclasses, okay, that means child classes. Now we shall go for a proper interview answer. Okay, hey, what is overloading and overriding? Sir, overloading is a concept of object oriented programming when a class has multiple methods with the same name, but still it differs in the parameters. So on the other hand, overriding is also a concept of object-oriented programming when a subclass provides a specific implementation of a method or a different version of a method that has already been defined in its superclass, sir. Even you can give this kind of small example if he asks, and it will be over. Okay, now I think our second task of interview question is also completed and hope you understood. Now we shall go for our next task, that is DSA. Come on guys, let's move to our third task. Okay, let's dive into our third task and the most important task, DSA round. Okay, here is a problem from leak code named as TwoSum, asked in very big product-based companies like Amazon, Google, Flipkart, and many more. Come on, let's go to the question description. Given an array of integer nums and an integer target. Okay, he gave us an integer array nums and an integer target. Superb, understood, very simple. Next question. return indices of the two numbers such that they add up to the target. Okay, in simple terms, we need to find two numbers here whose sum is equal to target. But wait a minute, there is a small catch. Instead of numbers, we need to return indices. Here, look, 1115, sum is not 9, 711, sum is not 9, 27, yeah, sum is 9. So instead of returning 27, we need to return their indices, that is 0, 1 as the output specified here. Similarly, in the second example, target is 6. Now we shall start adding numbers. 3 plus 2 is 5, not equal to 6. 3 plus 4 equal to 7, not equal to 6. 2 plus 4 is equal to 6, which is our answer, but return indices 1, 2. Similarly, even here 3 plus 3 equal to 6, return 0, 1. Their indices. Here are the constraints of the problem, which are in the integer range itself. Okay, now we shall go for an initial approach which every coder thinks when he sees a problem. He may be a noob or a pro. That is force, brute force. See, now basically what happens in this code is, for instance, let us take an example, something like 3, 7, 2 and 9. And also remember, he does not guarantee us the numbers are sorted. Okay, don't confuse. And let us assume the target is 11 here. So basically what we do in this code is, in the first loop, we choose an index number 3. And the numbers after this index, we check, can any of them produce the target 3 plus 7? No. 3 plus 2? No. 3 plus 9? No. Then again, I increment the index. Again, I choose this 7 as my I, and I check if any of them can yield the output of 11. No. Finally, 2, 9 will yield the output of 11, which took many steps here, 3 and 2 and 1. It took us 6 steps to produce the answer. Okay, but still I submitted this solution on heat code for the first time, thinking I'm something kind of pro. And look at what happened. I was something in 0.17%, and I got really very happy that I am doing something. But the thing is, I am not in top 0.17%, but I'm in bottom 0.17%. Wow. That means 99.9% people are above than me. So when I understood the reason for this worst time complexity and just beating 5% of people is my time complexity of code is of n square. As I placed loop in a loop where each loop will run around n times, it produces a time complexity of n square. Now I need to find a solution which can do my problem in less time. That is something like O of n. That means it should complete or compute the answer just in one single loop. Can I do that? Yes, we shall discuss a small concept for that. Okay, the most important concept required to solve this problem, the greatest data structure ever invented in computers, is map. Oh, what is speciality of this map? Why it is that much special? So it is called one of the greatest data structure. Yes, let me explain you. Look, generally what happens in an array is, it uses indices in order to store values, where indices start from 0 and go until the array's end. Okay, here the catch is that we cannot change these indices. Right, see, suppose if after this fun, I say, I don't need 2, I don't need 3, straight I want 4. No, you can never do that kind of thing. Okay, that is the problem due to which this array takes more space. But this map, so when scientists create the concept which we need to know to solve this problem is one of the greatest data structures of all time created in computer science, termed as map. Okay, why is map so special? First, we shall understand how arrays work. Basically, arrays have something called indices starting from 0 right to the end, where we can store a value in each index. But there are two main problems in this array. Okay, the first thing is, okay, I started with 0. I gone to 1. Now, if I directly want 4, That means I'm saying if I want to skip this 2 and 3, I cannot do it. To create a 4 index, I need to surely have a 3 and 2. So tomorrow, if I need something like a billionth index itself, I need to create 0 to 1 billion for sure. I cannot skip this. It's the first problem. Second problem is, okay, now here we are dealing with numbers. Suppose instead of 1 here, I need a different index name like a character or string like apple. I cannot do it in array. Surely I need to start from 0, 1, 2. They're only numbers and I cannot skip it. Observing these two major problems, a new data structure called map was introduced, where instead of indices, there are keys in maps where just instead of indices there, if we can just skip or just give a key and assign a value for each key. Something like, suppose I want to count occurrences of each element. Suppose if I want to count occurrences of 7, I need to traverse the whole array here each and every time. But here, once I store the occurrences in a map with a particular key called 7 and its value 3, simply I can call MP of 7. So in O of 1 time complexity, very easily I can get the answer as 3. So here we are improving the time complexity, which previously takes n, now it takes just 1. Now we shall know how this map concept can solve our problem efficiently. Now, look, here we shall take an example of 5, 8, 13, 4 and the target is 9. Okay, now instead of going to the further things, a small catch here. See, here our first index which we can see the number is 5. So ask a question. I want target 9. Okay. Now, how can 5 form 9 if I add a number called 4? Simply, it's like 9 minus 5 is 4. So simply I will check, did 4 previously repeat in the map? Did 4 previously repeat in the map? Okay. We just initialize the map and our map doesn't have any value. So what we do is simply we add this 5 in the map with its where its key is the number and value is the index. Okay. Now our second step, 5, 8, 13, 4. 5 is over 8. Now I came near 8. My target is 9. So 9 minus 8, I need 1. So does 1 exist in the map? Nope, it doesn't exist. So add 8 also to the map where key is 8, value is 1. Value is the index of the number in the array. Okay. Now next our third step, 13. So to find 13, and target 9, I need minus 4. Does minus 4 exist in the map? No, it doesn't exist. So again, to the same step, add this 13 to the map as the key with the value of its index as 2. Now my final step is 5 in the map. See, 4 is the number here. To form 9, I need 9 minus 4 equal to 5. So does 5 previously exist in the map? Yes, 5 exists in the map and its index is 0. So simply I will be returning this previously stored value 0 and the current index 4. So 0 comma 4 is the answer. So instead of checking brute force, instead of checking all the next things, here simply we check, does the complement, that means the consequent number which adds up, does it exist previously anywhere in the map? Simple. Okay, just 2 steps here. Is target minus a of I in the map? If it is, then simply return answer. If not, just add a of I to the map where key is a of I and value is its index, so that we can use it in the further problem. Okay. Okay, even though you not understood clearly, now we shall go for our live code on lead code. Okay, we shall understand it clearly now. Okay, come on. Here is the live lead code editor, and basically I'm solving the problem in C++, but for sure I'll be even showing you the implementations in Java and Python too. Okay, first step for any problem. To get satisfaction, we shall write the first line, initializing the size of the array. Nums.size is used to find size of an array. And then, as I said, our goated data structure map is now what we shall use. And more specifically, I'm using an unordered map as it is much faster than a normal map. Here, the data types of key is int, and the data type of value is also int, as both are integers, right? And then we shall name it MP for an instance, or your wish, you can use as you wish. And now we shall loop through our array as we discussed. For int I is equal to 0, right until the last index n, each time increment 1. Okay, now we shall go to our first step in our algorithm. Check if complement means the required value, I mean if it exists previously or not. Check if complement exists in map. Okay, so here we need to define complement. Am I right with the spelling complement? Yeah, I'm right. Int complement is equal to, what we need, target minus nums of I. So now we need to check if this particular complement exists in the map. So if MP dot find method is used to find if a given key exists in a map or not. Complement is not is if it exists, means before end if it exists. What we need to do is, of course, we can return our answer in the form of a vector. How? Simply, our first value should be MP of complement, means the index, and the second value needs to be our given index, MP of complement comma I. Okay, if it exists, it is really good. If not exist, simply add in map. Okay, now we discussed key is the particular number nums of I, and its value is the index is equal to I. Okay, so this is the main code. And finally, suppose assume that if we not find any result, which will just return a normal array. Okay, I guess this is the code. Now we shall submit this code and see how it works. Where is the run button, bro? Yeah, it's here. Run. Did it? Okay, it's accepted. Now we shall submit it and we shall see how fast does this code run. Come on. 59%. Oh, that's really good. See, we improved around 10 times from 5% to 59%. I'm submitting it again to see if there is any change, because this, okay, 77. See, this lead code is in this manner only, bro. Again, if I submit, I may get a 95. Okay, so we overall improved our time complexity from O of n square to O of n, which is perfect. And now I'll show you the implementations of Java and Python too. Come on, let's switch. Here is the Java code implementation, where similarly, with just a small change in syntax, a new map is being initialized, and instead of dot find, here we use dot contains key to find if a particular key exists or not, and we return the result. See, even we can skip the complement initialization to make the code much smaller, but it doesn't matter, bro. And even Python, it is much shorter. Look how small the initialization of the map is, and also we same to same we loop through the given array, and we check if target minus num exists, and if it exists we return, if not we add it, and if it doesn't, if no answer exists, we return an empty array or vector. So these are the implementations. I hope you understood it. We shall again meet tomorrow. Enjoy your debut. Smash it.